Hello and welcome to our next section in our parallel lines unit. Today we're going to be actually talking about parallel lines and transversals that actually go through them. And go ahead and get this down, pause the video if needed, as well as the title for your page. 3.3 transversals and parallel lines. Notice we're skipping 3.2. It's just the order of our book, and that's perfectly fine. So transversals and parallel lines. So we know what a transversal is. Parallel lines, we hopefully know what it is, but in case you don't know, parallel lines, simply put, are lines that never intersect in the same plane. Now, this is, make sure you have this symbol down. I'm going to put this in parentheses. They are two vertical lines that look like they're parallel. That's how they look. So it's in parentheses, so it is literally just this component of it, and that is used between segments. So if I, for instance, wrote like AB is parallel to CD, this is what parallel, the symbol for parallel. It's kind of like if you put perpendicular, right? It's a symbol stating that these two segments are parallel to each other. So here we have parallel lines, are lines that do not intersect and then in quotes, oh, we don't need that. I'm going to put this in parentheses, in the same plane. Now, for our sake, we're doing everything in one plane, in the same plane. So that's, for the most part, can be a little bit irrelevant, and you'll see what I mean. So if we draw two parallel lines, very, very important to understand this concept. First, let's draw these parallel lines. Two lines that do not intersect, they go on forever, and in both directions. Let's call this first one O. Let's call this line C, and then let's draw a transversal. Okay, so just transversal is a line that intersects two or more lines at very distinct points. We see those two distinct points here. And then here we could actually say that O is going to be parallel to C, because those are the names of the lines, right? And what's also important to note is this. When we actually have this piece of information, if this was, let's say, a given, I'm going to put G here, given O is parallel to C, then we actually should mark these two lines. Now, normally, if we have segments, we would mark segments with tick marks. That does not make sense for parallel lines because that would be very confusing. How do you know tick marks are for congruencies? Parallel lines use arrows. So in this particular case, we could do arrows pointing to the right, generally in the same kind of area. I could also do it on the left side of this, pointing the other way. And that would just mean that these two lines are parallel. Okay. Now we could also technically have this situation. If I have, for instance, these two lines intersecting with another set, we could say, for instance, let's call this A, B, C, and D. We could say C and D are parallel, so we could mark this with arrows. But then we could also say A and B are parallel, but we need to make a distinction because if these have one set of arrows and we want to say A and B are also parallel, we can't use one arrow and one arrow because it would imply that these are parallel to each other, which doesn't make sense because we clearly see an intersection. So we put two arrows if we wanted to show a second set of parallel lines that are not parallel to the first set. Okay? So that's just, hopefully you catch on. Hopefully that makes sense. I'm going to erase this. And we use more than one set of arrows if we have more than one set of parallel lines. All right, so here we only have one set of parallel lines, so we don't have to worry about that too much. We could also mark this diagram with angle numbers. Let's use blue. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Also, I forgot to mention, you could also technically use not just arrows, but triangles. So you could fill in if you close out that arrow to make it a triangle. That also works. It just states that they are parallel. So just another way to show parallel lines. Now, We didn't name this transversal. Let's call this transversal T just to keep it, just like the last set of notes. Here's the thing with parallel lines in the transversal. We have a whole bunch of congruencies that happen. So for instance, we have a whole bunch of angle pair relationships. And for instance, if I put, let's say, 60 degrees for angle 2, that means 1 is 120 degrees, 4 is 120 degrees, and notice this is in pink, you don't have to copy this down. But what happens if I actually say that corresponding angles are congruent? Well, that means angle 1 and 5 are corresponding, and they would be congruent, so this is actually 120 degrees as well. This creates a domino effect on the problem because now 6 is 60 degrees, 8 is 120 degrees, and 7 is also 60 degrees, okay? So that is actually one of the pretty much reasons or like GCRs, if you like the definitions that we have, is that if parallel lines, and parallel lines could also be shown as an angle or like slashes. If parallel lines, then corresponding angles are congruent. And we can clearly see that the moment I put in one angle, then corresponding angles are congruent. Okay? Now, if that's true, we could clearly see 1 is congruent to 5 corresponding angles, 2 and 6 are corresponding and congruent, 3 and 7 are corresponding and congruent, 4 and 8 are corresponding and congruent. But what happens when we actually talk about other angle pair relationships? What happens, for instance, if we have alternate interior angles? Well, alternate interior angles would include, interior angles would be 3 and 6. Alternate interior, opposite sides of the transversal, inside of our non-transversal lines, those are also congruent. So we could say alternate interior angles are congruent if we have parallel lines, that is. So this is the kicker. This is our if. If parallel lines are given, which it is, then alternate interior angles are also congruent. Well, what about alternate exterior angles? If we have parallel lines, then alternate exterior angles are what? Well, let's take a look. We take some alternate exterior, let's erase these first, and let's erase that. So one set of alternate exterior angles, let's do this in red, are, for instance, 1. The alternate exterior would be 8, 120. 2, alternate exterior would be 7. They're also congruent. So here we have our, if parallel lines, alternate exterior angles are congruent. So we have 3 different sets of congruencies if we have parallel lines in terms of angle pair relationships. So this is no coincidence just because of where they're positioned. But what happens with same side interior and same side exterior if we have parallel lines? So let's do another set. If parallel lines, what happens with this? If parallel lines, if we have to put commas here, then same side interior angles are what? Well, let's take a look. In order to be the same side, they're on the same side of the transversal. Same side interior means we're interior on the inside of the non-transversal lines, 3 and 5. And notice we have 60 and 120. These are by definition supplementary, right? And that's going to happen here on the other side as well. 4 and 6 are same side interior angles. They also add up to 180. So that means same side, if parallel lines, that's the kicker. Same side interior angles are supplementary. And last but not least, if parallel lines, then same side exterior angles are what? Same side exterior angles, same side interior angles are what? Well, let's take a quick look. Same side, the transversal T would be, and exterior would be 1 and 7. And we have supplementary again. 2 and 8 are supplementary, or 2 and 8 are same side exterior, and they're supplementary again. Okay, so we have supplementary here as well. If parallel lines and same side exterior angles are supplementary. Now, all of this hinges on the fact that these are parallel lines first. If we don't have parallel lines, then we cannot assume they are congruent. It's the moment we have this given statement can we assume that corresponding angles are congruent, or alternate interior angles are congruent, okay? Or same side interior angles are supplementary. But this has to be stated first. We have to know that these are parallel before we could conclude supplementary or congruent, depending on the angle pair relationship. Okay? So we'll definitely have more practice with this in class. If you do have any questions, please let me know. And we'll see this in GCRs and proofs. So be ready. I'll see you in the next one. Bye.